All right, so this is another recap video. So if you can fill out this whole page by yourself and you feel good about it, you don't need to watch this video. But we know we went through a lot of information in class yesterday. So if you're looking for some additional support, hopefully this video will help you. So we're just gonna go through the 3 examples that we have here and talk about all those key features of a graph. So the first thing, sorry, if you watched my last video, my lights went off last time. My lights went off again. Here we are. Apparently I don't move enough when I make these videos. Okay, so if we look at the key features, if we look at this first picture, we should be able to identify from the picture that this is an absolute value function. So because it's an absolute value, that's y equals the square root of x. So then we want to add those transformations that we see in to make up our equation. So we know that our graph is reflected over the x-axis, or it's flipped, right? Normally, our absolute value graph would be going the other direction. So this is reflected over the x-axis. And normally that point here is at 0, 0. So it moved left 2. So those are our transformations that took place. So when we write our equation, reflecting over the x-axis is going to give us a minus sign in front of our x value. And then inside with the x value is our right and left. So since we went left 2, we're going to have x plus 2. And then we didn't move up or down, so we're not going to have anything on the outside. That'll just stay blank. We don't need to put, you could put plus 0, but we don't need to. And remember, anytime you move right or left, the original equation has a minus sign, so when I move to -2, minus a negative would give me a positive 2. Or you can just remember that when you're inside with the x value, either you're inside the parentheses, inside the absolute value, or inside the square root, your sign is always the opposite of where you went. So I went to -2, so I have to put a positive 2 on the inside. So now when I look for the coordinates of the y-intercept, or the x-intercept, when I look for the coordinates of the x-intercept, I'm looking where my graph crosses the x-axis. So this is my x-axis, and it crosses right here at this point. So that point, that ordered pair, would be -2, 0. Because we're going to write it as an ordered pair, a coordinate. So then when I look for my y-intercept, I look for where it crosses my y-axis. So going along the y-axis, it crosses here at -2. So that ordered pair is 0, -2. All right, so then when we talk about our domain and range, remember your domain is your x values and your range is your y values. When you do your domain, you're looking left to right. When you do your range, you're looking down to up. So when I look at my domain, my graph, my absolute value function is going to keep going to the left forever and to the right forever. So when that happens, we're going from -infinity to positive infinity, right? Any x value, my graph is eventually going to touch on this function because this function is just going to keep going left and keep going right forever and ever and ever. And then remember, when we have infinity, since we can't equal to infinity, we have to use our parentheses instead of our bracket. Then for our range, starting down, now look, my graph is going to keep going down on both sides forever and ever and ever. So my graph, it has -infinity. It's going down. But it ends, right? It's not going to go up forever. The last point it reaches is this value here, which is the y value, 0, right? My highest y value of this graph is 0. And since I can equal y equals 0, right? This is the top of my y value. That means I'm going to put a bracket here. So my graph goes from all the negative y values until I get to 0, and then there's no other y values that are used to make this graph, this function. Okay, so then when I do increasing and decreasing, remember you look at the graph from going left to right. So as I look at this graph from starting on the left, I am increasing over here until I get to this point. And then I decrease on this side. I'm sorry, I don't have a red pen. I can find one before the next example. So I increase till I get to this point here, and then I start decreasing on this side. So this side is my -infinity, right? These are all my negative x values because remember, your increasing and decreasing is on your x interval. So where on the x-axis are you increasing and decreasing? So all of my negative x values, I'm increasing until I get to -2. That x value right here is where it changes direction. So from -infinity to -2, I'm increasing. And then from -2, I decrease through all of my other x values, right? As my x values get bigger and bigger and bigger, my graph keeps going down. So I decrease from -2 to infinity. And when we talk about our intervals, we always use parentheses because at that value -2, you're not increasing or decreasing. It's not going either way. So we can't call that a value that's included in our increasing and decreasing. So we just always use parentheses when we do increasing and decreasing values. All right, so then our last piece is our end behavior. So that is asking, where is your graph going to go at the end? Where is it heading the rest of the time? So as we look at our positive x values, so as my x values get greater, as I head to the right, my graph is going down. So that means my graph is heading towards -infinity. It is going in the down direction on the left side of my graph. On this left side, it's going down forever and ever and ever, heading towards -infinity. If I go to the right side of my graph and I follow that same thing, my arrow is pointing down. That means it's going down forever. So then that side is also heading towards -infinity, right? Both of my graphs, my arrows are pointing down. So that means their end behavior is -infinity. Okay, so let's look at our next example. So our next example, we should know that's the parent function of a square root. By that picture, we should know that that's a square root, which is y equals the square root of x. So now normally this picture starts at 0, 0. So we know that it has gone right 3. I'm just writing my transformations down here so I can keep track, and up 2. So those are the transformations that took place. So then when I write my equation, I have y equals, I don't need a negative because it didn't flip and it didn't stretch, so I keep it at nothing in the front. Right 3 means on the inside, I have a -3 with my x value. So I have x minus 3 on the inside. And then up 2 means outside of the square root, I'm going to add 2. So this kind of got messy. Let me rewrite it. The square root of x minus 3 means right 3, and then plus 2 on the outside means up 2. So that's my equation. So now, I'm looking for the coordinate of the x-intercept. So if I look, this graph starts here, and it goes forever and ever and ever this way. That's what a square root function does. It starts and keeps going that way. So if I am looking for where it crosses the x-axis, this is my x-axis. My graph is never going to touch that, right? It's going to keep going up. It's never going to actually get to the x-axis. So you can write none, you can draw a line through it, but there's never going to be an x-intercept for this function where it is now. Other square root functions may cross the x-intercept, but for this transformed function, it is not going to cross the x-intercept. And then if we look at our y-intercept, if we look at our y-axis, again, this graph is going forever and ever and ever this way. So it is never going to cross this y-axis. So again, you could write none, or you can put a line through it. So now, when we talk about our domain, we're looking at the x values from left to right that represent this function. So if we look, the first x value that we use is this value here, that 3. This is where my graph starts. And then it's going to keep going to the right forever and ever and ever. So it starts at 3. That's that first x value that we used. And then we're going to use every x value from then on out. So then it's going to go to infinity. Because 3 is a value that we can equal, we're going to put a bracket at 3. And then we always put a parentheses at infinity. So then our range is down to up. So the lowest y value that we use, right, we're not using any of these y values, -1, 0, -1. That first y value that we use is right here at -2. So that's that first y value, -2. And then this graph is going to go up forever and ever and ever. So it's going to use every other y value above that. One more time with the lights. If you're like me, you could use this as an exercise moment. And if you're still listening to the video, let me know what you think of our brain break exercise moment. Here we are again. Okay, so my range started at -2, my lowest y value, and then it's going up forever and ever and ever. So I go to infinity. Again, my y value, that -2, could be equal. So we'll put a bracket there, and then we always put a parentheses for our range. All right, so now we're going to talk about our increasing and decreasing. So when we follow our graph from left to right, if I start at the lowest part of my graph, which is right here, right? There's no graph down here. This is the lowest part of my graph. On the left, the first thing I see when I come to the left is this part of my graph. This is where I start, because when I go left to right, this is the very most left part of my graph, and I am increasing for all of it. And I'm going to keep increasing. This graph never decreases. It just keeps increasing forever and ever and ever. So that means it increases from, what's that x value that it's starting at? It's starting at -3, and then it's increasing forever. Right? The first place this graph starts, the most left part of this graph, is at 3, +3. I'm so sorry. The first part of this graph on the left is +3, and then it increases forever and ever and ever. So 3 is where it starts and increases the rest of the graph. And we already said this graph never decreases. It's always going to go up, so we can put none or put a line through that part as well. So now, when we look at our end behavior, where is our graph going at the end? So as our x values get bigger, as I head to the right, as I head this way, my graph is going up and up and up and up and up. That means it's going towards positive infinity, right? As I head to the right, my graph just keeps rising. Well, to the left, my graph doesn't do anything. My graph doesn't have an end behavior on the left because it doesn't keep going forever and ever and ever. So there's no end behavior for our left, right? It's not heading in any direction when you go to the left, right? We're not even using the values to the left of our graph. Okay, so let's look at this last one. So this last one is a cubed root. So y equals, and then we have the cubed root of x. So now, if we look at our transformations, normally this point of inflection is at 0, 0. So my graph went left 3 and up 1. So I'm going to write that down just so I have it. Left 3, up 1. So when I write my transformed graph, I have y equals, and then left 3 means inside the cubed root, I would have a +3. And then up 1 means on the outside, I have a +1. So that would be the equation of my transform function. Remember, when you go to the left, it's positive on the inside. It's the opposite of what you would think. And then on the outside, it's what you would think. Up is positive, down is negative. Okay, so now when we look at our coordinates of our x and y intercept, first, where it crosses my x-axis, so it crosses my x-axis here, at -4, so my point is at -4, 0. That's where it crosses my x-axis. Now, when I look for my y-intercept, I want to know where it crosses the y-axis. It crosses right here. That is not an exact point that we know. And actually, in the next couple classes, when we start using that graphing calculator, our graphing calculator can tell us what that value is. By hand, we don't really know, so we're just going to estimate. I'm going to estimate that that's roughly 2.5. So my y-intercept is at 0, 2.5. But over the next couple classes, we'll learn how our graphing calculator can actually tell us that exact value. So now, when I look at my domain and range, I'm looking at what x values, where does my graph go from left to right? Well, in a cubic, this graph is going to keep going to the left forever and keep going to the right forever. So all my x values to the left and all my x values to the right are going to be covered. So that means my domain is -infinity to infinity. Then if we think about my range, so again, this is our down to up. Starting below, this graph is going to go down forever as well as up forever, right? This side, it's going slowly. It's going to take a while, but it's going to keep getting lower and lower and lower and go down, down, down. And this side is going to go up slowly, but it's going to keep rising for infinity, forever. So this range is also negative infinity to infinity. So now when I need to write my increasing and decreasing x intervals, starting on the left of my graph, so the leftmost point of my graph, I am increasing, 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 increasing. At no point does this graph head down as you go from left to right. Remember, increasing and decreasing is as you read the graph from left to right. So if I trace with my finger, I am always increasing. I am always going up. So that means my increasing x value is negative infinity to infinity. And I do not have a decreasing x interval. It never decreases. So there is no x interval that it decreases. So now, this last piece is my end behavior. So as my x values go towards positive infinity, so as my x values get greater, as I head to the right, where is this graph going? This graph is heading up. So since it's going up forever and ever and ever, this graph is heading towards positive infinity. These y values are going to get greater as well. Then as I go to negative infinity, as I head to the left, as my x values go left and get bigger and bigger negative, so more and more negative, my graph is heading down. My y values are also getting more and more negative. So this is heading towards negative infinity. All right, so hopefully this video helped you kind of understand all of those key features put together. As always, if you have more questions, we can answer those in your Monday check-in.